Hello dear students, today we are going to discuss about chapter 3 Relational DBMS part 2. In this we'll be discussing about functional dependency and types, then Armstrong's axioms, normalization and its types, advantages and disadvantages of normalization, then unnormalized database anomaly problems. So let's start. The first thing that we are going to discuss today is functional dependency and its types. So let's start with very simple letters like X and Y. Here it is said that X determines Y. So this arrow symbol is nothing but it says it is determines. Okay, so X determines Y. Now here this X is called as determinant and Y is called as determined. So X is a determinant and Y is a determined. It is also said that Y is functionally dependent on X. So two things we come to know. One is X determines Y, or Y is functionally dependent on X. And it normally happens when Y is a subset of X. So this is an obvious case when Y is a subset of X, then we can say that X determines Y. So there is no other way. If Y is a subset, then definitely X can determine Y. Now there are two different types of dependency, or we can say functional dependency. One is called a trivial dependency. A dependency is called trivial when the determinant is determining the determined. In this example, X determines Y, and if Y is a proper subset of X, so the right hand side is a proper subset. So here Y is at the right side and X is as the left side. So Y is a properly determined by the determinant X. So to make it a trivial dependency, the right side must be a subset of the left side. Okay, so let's take a numeric example here. 1, 2, 3. Okay, so this is the left subset and it is determining 2, 3, let's say. Okay, so in the left hand side we have a bigger set 1, 2, 3, and in the right side the set contains 2 and 3, these two elements. So 2 and 3, this is a set which is a subset, or we can say a proper subset of the left hand side. Now it is obvious that the right side must be determined by the left side. So let's talk about the next type of dependency, that is called non-trivial dependency. And in case of non-trivial dependency, it's very important that the right side is not a proper subset of the left side. So let's take an example here. Alpha determines beta, and beta is not a proper subset of alpha. So if so, that means beta is determined by alpha, that is okay, and it is functionally dependent on alpha. But if it happens that beta is not a proper subset of alpha, so let's take an example. Let's say in a table there is a field called ID. For each individual ID, there is a unique name which can be determined. So if we know the ID, then we can determine the name. But in the right side, if we look into, the name field is completely different than the left hand side. Left hand side, there is what? ID. So ID is determining name, but there is no subset relationship in between these two. But still ID is determining the name. So this is called a non-trivial dependency. Okay. And similarly, there could be some other relationships which are also can be called as non-trivial, but the main thing is that the right hand side of the relationship must not be a proper subset of the left. That means at the left hand side. So that is how the non-trivial dependency can be explained. Now let's move on to the next discussion. So the basic building blocks of the functional dependency is Armstrong's axioms, which is very important to understand each and every concept of functional dependencies. Now Armstrong, who set 3 axioms at the very beginning, and from those 3 axioms 3 more are being inferred, okay, or derived. So let's look into the first 3 rules of Armstrong axioms. The first one is called as the reflexive rule. That is the first rule, inferred rules number 1. So IR1, it is represented as. Now if we talk about this reflexive rule, it says that y is a subset of x, then x determines y. So this is the symbol how the narrower side represents the subset and the open side, this is the set symbol of subset. The right side here where the narrow side is there, that is the subset, and x where this side is open, so this side whatever set is there, that is superset. So x is the superset of y, and in turn we can say it y is a subset of x, so it can also be written like this. Okay, so whatever way we write, in this way or in this way, doesn't matter. Main thing is the right side y in this relationship is a subset of x. That's it. So this is the first rule. Okay, now coming to the next rule, which is called as augmentation rule. This is also very easy to understand. I will tell you that if the first rule is there already, x determines y, then in this particular relationship x determines y, if we union another set, that is z, look into this example, z is union with the sets of the functional dependency, x is determining y or y is functionally dependent on x. in this relationship, we simply add z, right? So after adding z, the functional dependency still holds. This particular Armstrong axiom rule is known as IR2, that is augmentation rule. That means z is augmented in the both side. Now the third one, or IR3, that is called as transitive rule. Okay, so the transitive rule is something where the left side determines the right side. That means x here is the left part, and in the right side there is y is determined, and in the same way y is determine z. So x determines y and y determines z, then x must also determine z. So this is the flow where x is determining y and y is determining z. So from this particular relationship or functional dependency set, we can have this particular relationship. So the third rule of Armstrong axiom, it establishes this particular notion, or this is the axiom statement, that x determines y and y determines z. If these two holds, then x determines z. So there is no direct determination of x determines z, but in just via y, x can determine z. So this is how the transitive property or transitivity property holds. Okay. Now coming to the next one, and the first three that we learned is the basic rules of Armstrong. Now we will talk about the inferred rules. All are inferred, but these three can be proved with the help of the first three. So the fourth rule is basically called union rule, and here we know that if x determines y is the first functional dependency, that means y is functionally dependent on x, and x also determines z. Here, if these two functional dependency holds, and you see at the left side both are same, and we know that the left side is a superset of the right side according to the first rule, that is reflexive rule, where we say that if right side is a subset of the left side, then that is called as reflexive rule, and left side determines right side. So here x determines y and x determines z. These are the two relationship that holds. Then we can easily combine the right sides and we can do union. So y and z, they are being unioned, and x can determine this y union z. So this is the rule number 4, or union rule, right? Now coming to the next rule called decomposition rule. In decomposition rule, it is just opposite to the union rule. The opposite means x determines yz, that is given. Then the first two relationships that from where the union rule was derived, so we simply decompose it. So that is why it is called a decomposition rule. And a decomposition rule is known as project rule as well. So from this composite functional dependency x determines yz, we can separately, or in decomposition, we can write x determines y as well as x determines z. So this is just reverse of union rule. Okay, or it is called as decomposition or project rule. Now coming to the last but not the least, pseudo transitive rule, that is IR6. Here first two relationship we see here, X determines Y, so Y is the subset, and YZ determines W. Alone Y is not determining W, but Y union Z, this is determining W. So according to third rule, it was like X determines Y, Y determines Z, so X determines Z. But here X determines Y, YZ determines W, then in this YZ there is a part called Y, and in this particular functional dependency, X is the superset of Y. Suppose Y is 1, 2 and X is 1, 2, 3. So in this particular relationship or functional dependency set, if we replace Y by X, so instead of Y we are typing X, that we can do because Y is a subset and X is the superset, right, according to the first functional dependency. So X is the superset, that is Y. Instead of Y here we can write X. So XZ can determine W easily. So this is the pseudo transitivity rule, and this can be proved with the help of transitivity, that is the third rule. Now we'll discuss about the normalizations. What are the different normalizations we are going to discuss and what it is. So normalization is the process of organizing the data in database, and the second point is normalization is used to minimize the redundancy, and that is very important. But the redundancy mean not only repeating or repetitive data, but also that data must be unnecessary. So if it is unnecessary repetition of data, then that is called redundancy, and that we are eliminating or minimizing or alleviating. And we try to eliminate the undesirable characteristics like insertion, updation, and deletion anomalies. So normalization divides the larger table into smaller table and links them using relationship, that is integrity constraint. You can sometimes say foreign key constraint. And the normal form is used to reduce redundancy overruns, right? So these are the normal forms. We'll put on lights: 1NF, 2NF, 3NF, BCNF. BCNF is for voice chord normal form, 4NF and 5NF. Now this is a very brief overview of these normal forms. So 1NF says it contains atomic value, 2NF says there is full functional dependency of all non-key attribute on the key attribute, or we can say the primary key. 3NF, it is a transitivity relationship must not be there in a table, then we call it 3NF. 4NF is no multi-valued dependency should be there, and it must be in voice chord normal form, then no multi-valued dependency. And 5NF says that there should be no joint dependency, or we can say there should be joining of decomposed relation, but that should be lossless, right? So these are the different normal forms that we are going to discuss in the upcoming sessions. Before we delve into the normalization parts, that is 1NF, 2NF, 3NF, and so on, we should know what are the advantages and disadvantages of normalization. Now, if we normalize the database, then it should be ACID compliance. Now, what is ACID, that we will discuss in the chapter called transaction, where the transaction follows some ACID property. So atomicity, consistency, isolation, and durability. So those property will be discussed later. Now the advantages are for normalization is like updates run quickly. If it is normalized, the database is, then the update run is very quickly. The insertion also runs quickly, and tables are typically smaller. Not all the data are stuffed in a single table, so they are divided into parts and they are stored in different tables, right? So this is how the tables are organized. Now data integrity and consistency is also an absolute needed thing here. Now these were the advantages of normalization, but there are some disadvantages as well. Now the drawbacks, if we talk about, since data is not duplicated, so table join are required, and we know that join is a complex thing and that makes queries more complicated, and thus read times are slower. That is very crucial thing for normalized database. We need to join tables to reconstruct the data. Since joins are required, indexing does not work as efficiently, right? So if joins are required, then the indexing doesn't work efficiently. Now, if the database is unnormalized, then there are some anomaly problems, and there are three types of anomalies: the insertion, updation, and definitely the deletion anomaly. So updation, we can say modification as well. So if we start with the insertion anomaly, basically if we give an example, library database that cannot store the details of a new member until that member has taken out a book, right? So from the library, if a member has not yet taken a book, till then we are not able to insert a data, because in the library table, the person who is going to borrow some books from there, that database is going to be stored in the single table. Basically, if we do not normalize the database, then we overstuff every kinds of data in the single table. So that may lead to the insertion anomaly problem, because when the first user is coming, or the first member of the library is joining or added, he might not, or she might not borrow books in the first day, because he or she has to choose it. So in that case, it will be creating an insertion anomaly problem. Now what about the deletion anomaly? Like if we want to delete something, let's say deleting a book loan from a library, member can remove all details of the particular book from the database, such as the author, book title, etc. Suppose a borrower or a candidate who has borrowed 3 books, and now I want to remove one book from his borrowing. Now every data is stored in the single table. In that case, that means it is not normalized at all. So what will happen if we remove one uh, member, remove one book? That means I actually want to remove the borrowing of one book, but if everything is stored in the single table, then deleting that book will lead to a problem that the entire book will be removed from the database. Okay, so along with all details of the book, like author name, title, etc., right? So this is a deletion anomaly problem could occur uh, because of the unnormalized database. Okay, then again, modification anomaly also may occur. Like incorrect data may have to be changed, which could involve many records having to be changed, leading to the possibility of some changes being made incorrectly. So this is also very important aspect of database management system and normalization. Okay, so that's all till today's discussion. Thank you so much for joining me, and in the next part we'll be discussing about the first and second normal forms.